At its most basic physical level, digital data is incredibly fragile. A deleted file, a modified timestamp, or a hidden executable is often represented by a single magnetic charge flipping state on a spinning platter. Because data is so easily altered or destroyed, the primary goal of digital forensics goes beyond figuring out what happened during a cyber incident. The objective is to capture that volatile data so accurately that it can survive aggressive cross-examination in a court of law. As corporate litigation and cybercrime investigations expand, courts have established strict standards for exactly how digital evidence must be handled. Investigators have to follow a repeatable, well-documented set of steps so that any independent analyst could perform the exact same process and yield the exact same results. Any deviation from those established precedents gives opposing legal counsel the leverage to invalidate the findings entirely, jeopardizing the case. To guarantee that repeatability, every digital forensics investigation follows a strict pipeline. This diagram maps the standard process, moving through the pre-investigation, investigation, and post-investigation phases. A courtroom treats digital evidence as valid only if the entire sequence is flawless. If the chain of custody breaks at any single phase, the underlying data becomes legally useless. The moment a breach or incident is discovered is the most legally vulnerable. This diagram outlines the three distinct groups of personnel typically involved in a first response: non-forensic staff, system or network administrators, and laboratory forensic staff. If non-forensic staff discover the incident, their only mandate is to secure the physical perimeter. They take notes, photograph the area, and ensure the computing systems remain untouched until trained investigators arrive. System and network administrators face specific restrictions. While their daily job is to monitor network operations, during an incident, they must not perform any action unless explicitly directed by an incident manager or forensic analyst. The instinct of an IT professional is to isolate the threat, patch the vulnerability, and reboot the system to restore normal operations. In a forensic context, doing so destroys volatile data in the system's memory and overrides critical log files. When laboratory forensic staff take over, they follow the 6-stage protocol shown in this grid. Stages 1 and 2 require methodically photographing the electronic crime scene and conducting individual interviews to gather preliminary information. No investigator attempts to extract data from the hardware at this point. The first responder's mandate is preservation, not resolution. Their objective is to freeze the digital and physical scene exactly as it was found. Once the scene is secured, the process shifts to the pre-investigation phase. This takes place away from the incident, inside a secure forensic laboratory. Before a single device is analyzed, the investigation team verifies all legal prerequisites. This means obtaining search warrants and ensuring explicit legal authorization to seize and examine the electronic devices. The team then establishes the scientific parameters. They outline the budget, assign personnel, and validate the specific hardware and software tools they will use for the extraction. This lab validation acts as a legal shield. If an investigator uses unapproved, outdated, or pirated software to pull data from a hard drive, opposing counsel will point to that unvalidated tool as a potential source of corruption. Pre-investigation ensures the scientific environment is completely legally sound before any data extraction begins. With the lab validated, the workflow enters the investigation phase. This is where technical expertise is actively applied to the hardware. This timeline diagram outlines the process flow for planning the search and seizing evidence. Physical seizure requires navigating specific complexities. Investigators execute distinct procedures depending on whether the target computers are powered down, currently running, or actively connected to a wider network. Once collected, electronic evidence is packaged carefully for transit. Storage media and mobile devices are placed inside specialized signal-blocking bags to prevent them from connecting to wireless networks, protecting them from remote wiping commands. Safely inside the validated lab, investigators begin the data acquisition step. This acquisition step operates on a single, strict rule, highlighted in this document. Original evidence should never be used for analysis. To examine the files, the investigator connects the suspect device to an analysis machine using a hardware write blocker. This tool physically blocks any data write attempts from the investigator's computer while allowing read operations to flow outward. Operating safely behind this write blocker, the forensic software extracts a bit-for-bit mathematical duplicate of the drive's contents. All subsequent analysis is performed entirely on this clean copy. Generating this write-protected duplicate is the only way to prove in court that the investigator's examination did not accidentally alter timestamps or contaminate the original crime scene. Investigators now scrutinize the forensic duplicate. This slide details the 6 main activities of the data analysis phase. Analysts comb through the copy, isolating useful information by examining file contents, cross-referencing file creation and modification dates, and tracking exactly where files were physically stored on the disk. They take these isolated data points, such as log entries and user access records, and sequence them to generate a chronological timeline of the security breach. This process often requires sifting through massive volumes of electronically stored information, decrypting locked folders, and repairing corrupted files to categorize the data based on its relevance. The analysis phase takes millions of scattered fragments of binary code and organizes them into a single narrative that identifies the root cause of the incident. The technical work concludes at the final node of the timeline, the post-investigation phase. Finding the evidence is only half the job. The investigator must now translate weeks of abstract hexadecimal code, network logs, and file paths into a formal, structured legal document. This comprehensive investigation report has a specific target audience. It must clearly explain complex technical conclusions to prosecuting attorneys, judges, and jury members who likely have no background in computer science. The final test for the digital investigator is taking the stand to present these findings. This slide outlines the typical procedure for testifying as an expert witness. Notice the hostility built into steps 3 and 5. The opposing counsel's explicit job is to discredit the expert witness and ruthlessly cross-examine the methods used to collect and analyze the evidence. Defense attorneys know that attacking the raw data is difficult, so they attack the methodology instead. They look for process vulnerabilities, a staff member touching a keyboard, an admin rebooting a server, or unvalidated lab software. The expert witness survives this scrutiny by relying on the rigid documentation created throughout the timeline. They present the intact chain of custody, proving that from the exact first response, every action was legally authorized, scientifically sound, and meticulously recorded. Digital forensics relies on the architectural construction of a legally impenetrable chain of truth. When the methodology is completely flawless, the evidence stands on its own.